A11, A12. This is too small. Okay, let me write this bigger. A11, A12, A13. Okay, the partition, and then B1, and then A21, A22, A23, B2, A31, A32, A33, B3. Okay, so the whole idea of Gauss elimination is this. Let me open up a new file here because I think I'm running out of space there. Okay, so so this is the one. So the idea is that we have A11, A12, A13, A21, A22, A23, A31, A32, A33, and then B1, B2, B3. So the whole idea is, let's say this is R1, R2, R3. So this is the first row, second row, and third row, original one. So what we want to do is we need to eliminate. Okay, and we need to eliminate. So this is first iteration. After first iteration, what we want to do is we want to have A11, A12, A13, and still B1. And this is still R1. And this is what we call R2 prime, which is after first iteration, and R3 prime after first iteration. So after first iteration, we need to make this 0 and 0. So this becomes A22 prime after the first iteration. First prime is just first iteration. A23 prime and B2 prime. And for your information, that A22 okay, A22 is not equal to A22 prime is not equal to A22. Okay, A22 prime means after it has undergone a first iteration, first iteration. And then we have A32 prime, A33 prime, and B3 prime. Okay, so this is the idea. And of course, for this, what we need to do is that R2 prime is just R2, which is the original second row, second row minus A22 over A21, sorry, A21 over A11, which is this divided by this. This is the what we call the factor times R1. Okay, and R in such a way that for every element in that row, okay, and R3 prime J, R3J minus A31, A11, R3J. So what you need to do is just to find this fraction here. This factor. So this is very organized. This is very organized. So if you do this correctly, you get 0 and 0 over here. So after the second iteration, okay, for the second iteration, what you get here is just still R1. My brain is not thinking straight this morning. Still the leftovers COVID, I guess. R2 double prime, which is after the second iteration. This is only first iteration. This one is after second iteration. So this become A11, A12, A13. This one is only 0 and 0, A22 prime, A23 prime. Now this become 0 and this become A33 double prime. And this is B1, B2 prime, and this 3 double prime. So what is R3 double prime? R3 double prime is just this number divided by this number, which is R3 after the second iteration minus A33 over A23 times R 2 prime. Oh, this is wrong. This should be R1. This one should be R1, eh? This one. R1J. Okay, so this is the idea. This is the idea. So this is what we call the forward elimination. Forward elimination. So this is going this way. This is what we call forward elimination. What we are doing, we just eliminating all the we do not want here. Because we want to make this triangular, right? We want to make the coefficient matrix triangular or upper triangular. So we eliminate this, we eliminate this, and this. These three numbers. Now, the next process is what we call back substitution. Okay, because now we know that A3, A33, sorry, not A33. In this case, maybe X3. X3 is just B33 double prime over A double prime B3. Okay, when you get A, when you get X3, you know X3 over here, then you get your X2. Once you know X2 and X3, you can substitute X2 and X3 in this equation, then you get your X1. So this is the idea behind back substitution. So this is a very systematic way. Very systematic way. So what happened here is that this is not systematic. Sometimes it's R3, this is 5, 17, 26, 347, and so on. So this is what I said, these are not Gaussian elimination. These are just elimination. So you get the correct answer, but you use the wrong method. Okay, you go. So what about Gauss-Jordan? Gauss-Jordan, the problem is Gauss-Jordan to me, personally, I do not like to use Gauss-Jordan. It is time consuming for me because elimination process is tedious. So what you need to do is in Gauss-Jordan, there's no such thing as back substitution, only elimination. So you eliminate everything. So you eliminate the upper diagonal and the lower diagonal and leave the diagonal as 1, 1, and 1. Okay? So what you have is in Gauss-Jordan, what you get is this. And then you say B1, B2, or maybe let's say C1, C2, and C3. Okay? So basically, so you know that C3 is this value, X3 is this value, X2 is this value, X1 is this value, straight away, without doing the backward substitution. So that's the difference. That's the difference. So make sure you know, which is which. But the most important thing here is that you must know how to set up the equation. the three equations, for example, in this question. Okay, for example, in this question. So this is one of the common mistakes. A lot of you are doing this. A lot of you are just doing elimination, not Gaussian elimination. So let's look at the second one. Okay, this one is hanging. Yeah? This one is hanging because I asked for the value of F1, F2, F3, and F4, but there's no answer here. It's not giving me any answer. He wants me to answer this for him. So that's why I just put these two question marks. Yeah? I think a lot of you are doing this too. Okay, and this one, all right, this is very interesting. Yeah? This is a very simple problem, but what I want you to know here is that the idea of mathematics here, if we have if we have four unknowns, we must have four equations. Yeah? And note, if you do the elimination, in this case, if you do an elimination here, you note that after the second iteration, what you get here is this. Note this thing here. Note this thing here. Note these are the same, right? So which is telling us that equation number 3 and equation number 4 are the same equation. So basically, in this case, there are four unknowns, which are F1, F2, F3, and F4. But if you look at this is all zeros. Okay, this is all zeros. And you know that this basically is non-existent. So we have four unknowns, we have three equations. Okay, as you can see that the third and the fourth equation here are the same one. Okay, and then you get 0, 0, 0, 0. And I don't know how this student get F4 equal to 0. How do you get F4 equal to 0? Is it because you look at this is F4, 0, F4 equal to 0, and then F4 equal to 0 divided by 0. Can anybody punch in your calculator and see what is the value of 0 divided by 0? Anyone? Okay, let me use my calculator here. What does it say? Oh, very bright. It says undefined. It says undefined. So we do not know what's the value here. It's undefined. So basically, we do not know F4. What is the value of F4? F4 is not equal to 0. And in this case, F4 is not equal to 0. F4 is not equal to 0 because we have four unknowns, but we have only three equations. So this is why I'm asking the student, how do you solve four unknowns using three equations? Okay, unless one of these four are given. Okay, unless one of these four are given, which means now it's a three equation with three unknowns. Okay, then we can solve the problem. Okay, this is the law of mathematics. If you have if you have four unknowns, you must have four equations. Okay, there's no excuse. Right, so this is, again, a lot of you are doing this. Okay, a lot of you are doing this. All right, so next one. Okay, I think this is the same thing here. So this student is commenting that F4 is equal to 0 as there is no traffic flow all along the street. So, is this true? How can you verify this? How can you verify this? Is this an assumption? Okay. Unless if the road is closed, then there's no traffic. But it didn't say anything about road closure. Okay. Again, I think most of you, if you've gone through the elimination correctly, you get this and you get this. Get this. Okay, and I think I read some of the comment. It says that using Gaussian elimination, okay, you cannot solve for all this. But using other method, you can. So can you use your calculator and see what is your solution? Because somebody commented that you cannot use Gaussian elimination for this problem. Actually, whatever method you use, because this thing violates the law of mathematics. For example, you have 4 unknowns, you must have 4 equations. There's no excuse. Again, there's no excuse. Yeah? Whatever method, calculator ke, supercomputer ke, because of this requirement is not met, then you cannot solve. Cannot solve. So there's a lot of solutions here because we need to know one of the 4. Then we can solve the problem. Okay, now this is very interesting. Okay, so this is correct. This is the setting up of the equation. Okay, so once you get this equation, you can use this. You can use Gaussian elimination. You can use Gauss-Jordan. You can use Gauss-Seidel. You can use Jacobi to solve this unknowns. Yeah, C1, C2, and C3. And again, this is Gauss elimination, but I want to highlight something about this. So when this student is using Gaussian elimination, she got all the answers wrong. Okay, then in the next part, I say use Gauss-Jordan elimination. So, okay, again, this is not properly elimination. Okay, this is okay, this is fine. But using Gauss-Jordan elimination, the student got everything right here. So my question here is, okay, you know that your 2 answers, your 2 sets of answers are different for the same equation. What can you conclude? What can you conclude here? Okay, you know at least one of the 2 sets of answers are wrong. Okay, so please double check lah. Please double check. So I'm training you not to be a calculator, but I'm training you to be a thinking engineer. Okay, so you have at least there's a bell ringing somewhere saying that, oh, my Gaussian elimination gives me different result than my Gauss-Jordan method, but the equation are all the same. So what is wrong here? What is wrong? Always, of course, a 3x3 matrix, you can always check this with your calculator. So this is again a practice of practice to me to be a good engineer, thinking engineer. So had the student correct this, he or she get more marks. Yeah? Okay, but this is very unfortunate because this is just basically punching calculator training in this case, just to punch the numbers. Yeah? So I hope you will not do that in the test. Unknown. Okay, this one. Iterative methods. Iterative methods, I think in the textbook, we covered 2 methods. One is Gauss, again, Gauss-Seidel, and not Gauss, Jacobi. So what are the differences between these 2 methods? Both are iterative method, but what is the difference here? Okay, in this case, the assumption is that C2 is 18, C3 is 13. My question is why you pick this number? Is this because of from Gaussian elimination, the answer is 18 and 13 for C2 and C3? Okay, if you read the textbook, it says that for Gauss-Seidel, your first iteration, not your first iteration, your initial guess is that in this case, C1 equal to C2 equal to C3 equal to 0. And then for Jacobi, C2 equal to C3, which is must equal to 0. And this is stated in the textbook. I think I posted this in e-learning on my lecture slides, on my lecture slide. So this is why I said, please read the textbook. Okay, this thing can be found in the textbook, just in case you don't know what value to use. Okay, so anyway, in this question, I didn't want you to solve this. I just say set up the equation and what are the assumptions. Okay, some of you are very diligent enough to finish it, to do the iteration and so on, which is okay. But at least this one, this one is, even though it's short, please double check this one. Yeah. So this is again another, I think, a major mistake. A major mistake. Okay, let's look at this one, unknown 9. Okay, so what is this problem here? What is the problem here? Okay, he has, or the student has all this. Equation number 1, equation number 2, equation number 3. And we know that the unknowns are C1, C2, and C3. Again, this one is C1, C2, and C3. C1, C2, and C3. So what do you think is the mistake here? What do you think is the mistake here? Anybody?
Matrix.
Excuse me?
Element of the matrix. Should
The
be
matrix
C1
is
and
wrong.
C2 and C3. Yeah.
Okay, so Abdul Rahman, you are correct. See, I don't know what is wrong here, but we note that if you expand this matrix, you see that this is 500 C1 plus 2C2 plus 3C3 equal to 17. Is this the first equation? Is this the same as this one? No, they are not. They are not the same. So remember that our system of linear algebraic equation, when we write it in the form of matrix, this is always the coefficient matrix of the unknowns, which is C1, C2, and C3. So this must be the coefficient of C1, C2, and C3. So this is 17, I don't know, minus 17. C2 is plus 2. C3 is 3 and must be equal to minus 500. Okay, so this is the proper way. This is the proper way of doing of converting the equation into matrix. Unfortunately, for this student, he used the same equation. He used the same matrix for his Gauss elimination and Gauss Jordan. So he got both wrong. He got both wrong. So I think this is just a very major mistake. Very major mistake. Okay, so about which method is easier, direct or iterative? Be very careful. Be very careful. I told you last time that iterative method is unstable. Sometimes it will not converge. Sometimes it will not converge. For example, I think I showed you last time. Let me show you my Excel sheet here. It's my Excel. Okay, so let's share my Excel here. Okay, I hope you can see my Excel. So this is note that these are the differences between the Gauss-Seidel and Jacobi. So this is Jacobi, and this is Gauss-Seidel. This is Jacobi, and this is Gauss-Seidel. Note that our assumption is that in this case, for Gauss-Seidel, this is 0 and 0. Oh, okay, so I made a mistake just now. So this is 0 and 0. We assume x2 and x3 0. Okay, for the first iteration and so on. And this is the one. So note that this is the correct equations. This is 17 to 3 minus 500 and so on. And you can see that the value after maybe after about fourth to fifth iteration, you can see that it is converging to one values. But note that if I just change this to -2, and you see that this is a big issue. It will not converge. This is diverging. It started with 129, go up until 600, 700, and so on. So this is just basically diverging. So this is the issue with iterative method, especially with bigger matrix. Okay, 3 by 3 we can see, because one of the reasons here is that this is not what we call pivot. This is not properly pivot. So now we will change that. We can see now it is converging. So be very careful. This is Gauss-Seidel. The same thing with Jacobi. If I just change this to -2, then again it will be diverging. Diverging. So the best way is to use elimination method. Elimination method. Even though I know it is not as easy as iterative method, but elimination method is much better. Much better. All right. So that's.
Excuse me, doctor. I have a question.
Yeah.
Example, if row 1, if I change the sign when I organize my equation, like I put it 17 and -2, -3, and 500, will the answer be different or no?
Which one? Second row? You change the sign.
First row. No, I mean first row for all the elements. If I change like plus 17 and -2, -3, and positive 500, will the answer be different?
It should be the same. It should be the same. So let's try this, right? -2, -3. 500, right? Should be the same. Because this is a matter of sign. Okay, by the way, a good practice is always to have your diagonal all positive. Okay, a good practice. In my case, what I did was all minus in my diagonal. All minus. This is important when you are doing your eigenvalue analysis. Eigenvalues, okay, you know that your eigenvalues is always at the middle, right? Diagonal. And diagonal, if you are doing vibration analysis, that is one of the reasons you learn this eigenvalue, eigenvectors problem. Part of it is used mostly in vibration analysis, or generally known as what we call modal analysis. If you take dynamics of structures, okay, you see that it is used a lot. It is used a lot. Okay, so in this case, the sign doesn't matter as long as the equation is correct, because this is basically what you did just now, just switching signs, right? You change this to positive, negative, negative, positive. So this has no issue. It's basically the same equation. Basically the same equation. All right, so that's assignment number 3. That's assignment number 3. By the way, I have written your assignment number 4 on e-learning. So it should be able in your account. It should be in your account this morning. But unfortunately, I haven't had the time to do the statistics yet. Okay, so now let's go back to let's go back to assignment number 4. Assignment number 4. What is assignment number 4? So let me close all this because it's taking up my memory. Taking up all my memory. Okay. Okay, let me see where is my assignment 4. Hopefully I have my solution with me. So, okay, assignment number 4. Okay, this is assignment number 4. So you might want to download your paper now and see what you did wrong, and we can have a discussion right now. Okay? Can you do that, please? Download it now from e-learning and see where you get it wrong. Because I don't know if I have time to compile where are your common mistakes. I think I finished this about 2 a.m. this morning. Okay, there are some serious issue. There are some serious issue with your answers. With your answers. Okay, so have you seen your paper? Have you downloaded the paper and see your mistakes? Okay, let me. Oh. Okay. This is from just my memory. Hopefully, I get everything. I get every comment right here because normally I will have time to compile all the mistakes, but not today, not this morning, because of the time. Okay, please give me 1 minute because I need to erase the student name here. Okay. Oh, my PC is getting slow. Okay, so I'm ready with one of the students' paper. Okay, this is the paper. Okay, this is the paper here. So assignment number 4. Right, so the question asks for this, right? It says that consider a two-story frame structures shown in figure 1A, which can be modeled as a spring mesh system shown in figure 1B. Okay, this is my master's, my master's part of my master's textbook, a long time ago. This is one of the classes that I took, which is under earthquake engineering. So this is the dynamic of structures. So my university is top university for earthquake engineering. Number 2 in the US for earthquake engineering. Number 1 is UC Berkeley, which is in the West Coast, in California. My university is in New York, which is the East Coast. So we are the top 2 universities doing earthquake engineering. So all the professors are very good professors, and some of those basically are from UC Berkeley, top school, top school. So basically what I want you to do here is that to derive or to show, because this is the model, this is the problem here, this is the problem, and it can be modeled as this, which is a mass spring system. But in real life, you have one more, which is what we call a dashpot or a damper, because you do not want your building to shake continuously. Okay, so if you do that, then we have this. Okay, we have this. This is mass spring damper. So if you have mass spring damper, then it's become more difficult. So I do not want to do that. So this is just a mass spring problem, mass and spring problem. So consider a two-story frame structure shown in figure 1A, which can be modeled as a spring mass system shown in figure 1B, which is this one. Using figure 1B, prove that the equation of motion, using the equation of motion for both masses can be expressed in metric notation as this. Okay, so from this figure, it becomes this. But what the student did is that it the student proved it the other way around, basically from here to here, which is what I do not want. Okay, so I say please prove how to get this equation from the problem, not the other way around. So why? Because this is basically training using all your knowledge that you have. So this is just basically summation of forces equal to MA, which is your dynamics class, yeah? Which is your dynamics. Okay, maybe you argue with me that I've taken that a long time ago, so dah tak ingat, dah tak remember, you have forgotten about what is dynamics. No. Dynamics is used in a lot of places, in fluid mechanics, okay? And of course in vibration, in the vibration, or mechanic of machines. Okay, so a lot of you, when I mark your paper, basically you did a little magic. Okay, I do not have time to go through in details of your solution, and I believe all of you got these two right. Okay, but along the way, I know some of the math word is not correct. Okay, some of the math word is not correct. So, okay, so I just giving you a benefit of the doubt. So I give you all the points there. But the most important thing here is that how part C, part D, and part E. Okay, this is part of the numerical methods. Yeah, and this one is just your dynamics. This is your dynamics. So how do we derive that thing? How do we derive that thing here? Okay, let me open up my paper just now. What assignment? I guess assignment number 3. Yeah? Okay, so this is the paper just now. So let's do for the second question. Okay, so I don't know how you do your free body diagram, but let me do my free body diagram. Your free body diagram is just confusing. Okay, it is maybe I have doubts because either you have my old solutions and just copy my solution without even knowing what you are copying and submit it as your work. Okay, that is a lot, a lot of them. I can see a lot of those. So some of you, maybe this is the problem here. So I believe this is 2M, 2K, this is K, and this is M. So this is the problem. And some of you did the free body diagram as this. K, and then this is K x1 minus x2. this is M1 or 2M lah, M2 mass number 2, and then this is Kx1 minus X2. It was not very clear how you get your direction here, one thing, and a lot of you, maybe one solution is being used for a set of students. It says that assume X1 greater than X2. And my response to that is always, why? And please explain. Okay? I want you to understand what you are doing. I want you to understand what you are doing. Okay, because once you understand, then the problem becomes easy and the test will become easy. Okay, that was the whole idea of giving you all the assignments. And I mentioned several times, if you copy my solutions or your friend's solutions or my own solutions, it defeats the purpose. You will not know if you understand or you do not understand. So my question is, why is this? Why is this? Okay, and I think another set of students do it horizontally, and I think, okay, so I don't remember, maybe this way. Okay, I don't understand why it is Kx1 and why it is Kx2. Can it be the other way around? How do you determine that direction here? How do you determine that direction? Okay, so for those, even though you got maybe 10 over 10 for this assignment, please think about this. Okay, please think about this. I'm a little bit worried because I was marking this late at night, and again I'm rushing. Basically, I'm short of time, so I need to do this as soon as I can. So I don't know. I don't know if you understand or you do not understand. But remember, whatever you submitted, whatever you did, please make sure you understand what you are doing because test is coming soon. Test is coming soon. So how do I do this? How do I do this? Okay, mine is simple. Mine is simple. So, okay, remember, this is my master subject under earthquake engineering. So this is my, this is 2K, right? This is K. So this is at the, what we call at initial position, basically rest. So what I did now is that, let me do this and, oh, okay. So this is X1. So let me, this is X1, the direction of positive X1, and this is the direction of X1, X2. Okay, so let's look at this. Let's look at this. Okay, so what I'm going to do is to pull the top mass. Okay, to pull the top mass. So what will happen if I pull the mass? Okay, I'll pull the mass, and I know it will move, right? It will move. So now this is my initial position. This is my new position. Note that now this is my X1 and it is moving upward. So, sorry, this is X2. Let me look at the question. Let me look at the question. So I'm confused now. Which one is M1? Which one is mass 1? Which one is mass 2? So let's see if I have my solution here. Oh, okay. So this one is 1, this one is 2, eh? So now I understand. So terbalik ni. Should be the other way around, eh? So this is x1, this is x2, eh? Sorry for the mistakes. So now I know that my bottom mass move from that position to this position. This is my x1. And at the same time, this position, yeah, and note that if I lock, okay, if I put a link between mass on the top and mass on the bottom, if the bottom move by x1, so the top one also move by x1, right? By x1. But now we know that for mass on the top or mass 2, note that now this is the movement x2. Note that this x1 and this x1. So what we can say here is that part of x2 is x1 because the total movement for this mass is x2 and part of it is due to x1. So in this case, we know that x2 is greater than x1. Okay, this is what I'm expecting, yeah? When you say assume x1 is greater than x2. Okay, so now we know that in this case, the mass, the spring is extended. The spring is extended. So let's remove this this link here. So now we have m mass 2, which is this one is 2m. Yeah, 2m. This is 2k, and this is k. So this is the idea. And then once I pull it up, then I release the mass. So what will happen is that you can see that initially it was at 0, I pull it up, and then I release, so it will go. And of course, the bottom one will also oscillates. Okay, but I don't know the direction, maybe this is this way. Okay, so top mass and bottom mass. So now let's redo the free body diagram. Okay, so look at the spring. This spring is in compression or is it in tension? Abdul Rahman, can you answer my question?
Which one, Doctor?
The bottom spring, is it in tension or in compression?
Tension.
Tension. Okay, so the tension is
Yes.
this way, right? How about spring number 2?
It should
Tension or
be
compression?
compression.
Huh?
Compression.
Tension. Tension, right? When I pull, both are, the spring are in tension, right? So tension is always positive and it is away from the body. Okay, so this is 2k. And what is the movement of this mass? Because force is k, which is the spring constant, times the displacement, x. In this case, our k is 2k, and our displacement is x1, right? Okay, how about the top mass now? Okay, note that if this is k, this must also be k, because this is what we call the internal force, right? Internal force. So now, the problem here is what is the movement, what is the displacement of the top mass? Is it x2? Is it x1 minus x2? Is it x2 minus x1?
Minus x2.
Minus x2? x1 minus x2? So look at this. Note that I mentioned just now, okay, part of the movement of x2 is due to x1, okay? So basically, this movement, the total movement for the top mass is only this part here, which is x2 minus x1. So this is kx2 minus x1, and this is kx2 minus x1, because when you join these two forces, internal forces, it must equal to 0. So this is the free body diagram. Okay, there are some of you just got the equation without having the free body diagram. And I give a 0 on that. You need to show me the free body diagram, all the directions and so on. So in this case, we have the, let's say, top mass. Okay, top mass. Okay, let's say mass number 1. So the summation of forces, okay, mass equal to ma. And I received a question from one student confused about the direction of positive A. So is it downward or is it upward? He told me that in my first example, the parachutist, my A is going downward. Okay, my G is also going downward. Okay, my gravity. Note that in our parachutist example, okay, in our parachutist example, okay, G is downward, right? And of course, this guy is falling downward, so M, A is also downward. But in this case, which one is the positive A direction? Can you have, you are falling downward and your A is going upward? Can you have, if you are moving upward, your A is going upward? Can you have, which one is correct? This is your M, your X going downward, but your A going upward. Your X going upward, your A going upward. Note that MA is the change of momentum, right? So in this case, it is positive. A direction is positive according to X direction. If X is upward, then A acceleration due to the change of momentum must be the same direction as X. So in this case, my upward is positive. Okay, so because the initial assumption is that x1 and x2 is upward, so up acceleration is positive upward for both of directions. So in this case, for the top mass, we just have k minus k x2 minus x1 equal to m times a, or in this case, x double dot x, x2, yeah, sorry, x2. Okay, so this is one equation. And the bottom mass, okay, again, the same thing here, summation of forces upward is positive equal to MA. And this is the free body diagram. So positive K, Kx2 minus x1 minus Kx1 equal to 2m x double dot 1. Okay, so this is the two equations. So I made it very clear that there are confusion here, because I think in my case, my direction of the forces is consistent with the free body diagram. Okay, again, I do not understand. Some of you did, some of you just get this, ya. Macam saya kata tadi lah. Okay, you get this and you get this, which is 2kx1, and you switch x1 minus x2. My question is why x1 minus x2? Okay, why x1 minus x2? That is my question. Okay, why not x2 minus x1, which is more consistent with the free body diagram? Okay, so that is the issue. So I hope whoever has a different direction than my free body diagram, okay, understand what you are doing, yeah? Understand. Anyway, it is not for me. Again, the assignment is for you to make sure that you understand and prepare yourself for the test. Okay, so again, then we have this. Of course, you can do everything else. You should be able to prove. Once you get these two equations, I think using algebraic manipulation, you should get all the proven. You can prove all those. For example, this one here.
Doktor nak tanya boleh?
Yes. Siapa ni?
Faiz. The bottom mass tu kan negative 2k ke?
Sekejap.
Bottom mass.
Okay. Negative 2k bottom. Oh, sorry. Okay, so top mass. Okay, this one is 2kx1. So this one lah. Is that the one? Okay. So typo. My free body diagram is correct. Then when I transfer it from free body diagram to my equation, then I miss a 2 here. Okay, so sorry about that, but thank you for pointing out my mistakes. All right, so this is the one. Once you get these two equations, hopefully you understand. Hopefully you understand my standard notation here. Okay, my standard notation. Okay, anyway, this is just your review of your dynamics. Dynamics here. So nothing new. I do this a lot. I do this a lot because I was in the earthquake engineering program last time, so we do a lot of this structural analysis. We even do a real life house. It was on CNN. My lab was on CNN. Saya tengok, because my boss kata CNN is coming, dia kata nak film when we did the test. Dahsyat lah dia buat full scale house on a shake table and check the building. And we are trying to basically verify all the formulation dengan the experiment. All right, so that was a very good experience. Okay, so now you should be able to saya sepatutnya tak boleh cakap banyak, tekak saya masih belum pulih 100%. So, okay, you should get all these two equations. You should get all these two equations. So let's assume that you get this. What is the time? Am I out of time? Okay, we still have about a few more minutes. Okay, so what we need to do is, okay, so all right, so hopefully that you get this. You get this 3k over 2m minus lambda minus k over 2m k minus m km minus lambda, and of course this is amplitude of mass 1, amplitude of mass 2. Note that initially we were using x1, which is displacement. Displacement of mass number 1, and x2 is again the displacement of mass number 2. But we convert it to amplitude. Why? Because x is a function of amplitude times, if I'm not mistaken, is it sine or is it cosine? Sine, sine omega t. The displacement is sinusoidal because it is a function of sine. So x1 is a1, x2 is a2 sine omega t. So it's a function of time. So at time 0, maybe x1 and x2 is 0, for example. And it becomes, and this is what we call the amplitude. Okay, amplitude. And then this one should be equal to 0 and 0. So it asks for characteristic equation. And characteristic equation is simple. Basically, the cross multiplication, such as when you're trying to find the determinant. So in this case, it is just 3k over 2m minus lambda times km minus lambda minus k over m times k over m equal to 0. And what we want to do is solve for lambda. Solve for lambda. Okay, note that this is a quadratic equation in lambda because this is lambda times lambda, it becomes a lambda square. And because of that, we should have lambda 1 and lambda 2. Two lambdas, two solutions. Two solutions. So in this case, when you are doing modal analysis, you want to arrange your lambda in descending order, which means the top one first, the biggest one first. In this case, the biggest one is 533.333, and I think this is one. My PC is pausing here. Okay, 533.333 and 133.333. Okay, so some of you get the answer of 0.53333 and 0.1333, and this is wrong. This is wrong. Why? Because your K is 400 kilonewton per meter. Okay, so it is wrong because you didn't factor out that K here. So it should be 400 K, 400 Newton per meter. Okay, so this is the analytical solution. So in engineering, okay, when we are doing, for example, for 2-story building, there are 2 eigenvalues. For 3-story building, there are 3 eigenvalues. For 10-story building, there will be 10 eigenvalues. Okay, so I remember we did a project with Dr. Zaini as a head researcher, the principal investigator. We were doing vibration analysis for proton Ixora body. And I think when we did the analysis, we have 16 modes, which correspond to 16 eigenvalues. So how important are all these 16 eigenvalues? Actually, what we want to do is to find out the natural frequency. That is one important thing. But in earthquake engineering, the one that will destroy the building is always the one that has the biggest eigenvalue. So that is why, if you look at numerical method textbook, it says the first thing that if you look your textbook start with the largest eigenvalue first because this is critical. This will damage the building. This will damage the building if any vibration exists. So this is the one. So the next thing to do is to find out what is the, so this is the analytical solution. Analytical. So I think this was my question a few, I don't know, maybe 10 years back. This is my question. So the idea of my question here is to guide you through, to do it step by step. So the whole idea of trying you to asking you to do the analytical solution, because I want you to make sure when you do the iteration, it will converge to this value. So you know that your numerical method is correct. Can you excuse me for a while? This is killing me. Okay, so let's continue. So the whole idea is that to make sure that you are doing your iteration or your method correctly. So this is the idea, because I'm trying to help you get the best score that you can. But unfortunately, student did not realize this. Okay, did not realize this. So this is a guided system, a guided question in such a way that if you do everything correctly, there will be check and balance here. So the first thing is try to find the analytical solution so that you know when you do your numerical methods, your answer is approaching to this values here. So how do we do the power methods? So basically the power method is the same thing as this one, which is I do not have my solution with me here. Oh, wait, I think I have it in my calculator here. So okay, so when you substitute all the values given to you, you should get this as 400. This is minus 133.333. And this is minus 266.667 and 2666. And then this one is A1, A2, and this should be lambda A1 and A2. If you set it up correctly, this is what you get. Note that again, this equation, it says that your left-hand side and your right-hand side must be equal, right? So what you can do here is that when this one and this one are the same values, then you get your lambda. You get your lambda. Okay, then you get your lambda. So I believe I ask you to use 10 and 11 as initial guess, and I think I have my Excel solution here. Let's see. Okay. Okay, let's share this one. Share this one. Okay, I hope you can see my Excel here. Oh. Okay, so this is the coefficient matrix. This is my initial guess, 10, 11. This is the value that I get. Okay, so what I did here is that I get this value, 2533.33, 6.667. And then what I did is just to factor out the largest between these two. So this is the factor out. So, and note that I'm only taking out the positive signs, yeah? Positive sign, because eigenvalues must always be positive. Okay, so note that now this become my new guess. This become my new guess, which is this one here. So note that this is not an iteration. This will be my iteration. So up to 4 iteration is this one here. Okay, this is my 4th iteration. So this is 0 iteration because this is just the guess, the first guess. So when you repeat that, now I'm using this as my new guess for my first iteration, and this is what I get. Okay, now this is my guess for my second iteration. And of course, when you do this a lot of times, you can see that up to 11 iteration, you get the same solution as the analytical solution. So this is the idea behind power method. Power method. Okay, you need to explain every single steps, yeah? You need to explain all single step. For example, this take out the common, the largest factor out, and then the remainder here becomes the new guesses, okay, and keep iterating. In this case, I have also calculated the error, absolute error, and then I can use this thing here, the same problem, the same matrix here, and this is the inverse of this matrix. This is the inverse of this matrix, and I can use to find the smallest eigenvalue. In this case, the smallest eigenvalue is 13333, and this is the one. This is the one. Okay, after 4 iteration, this is very close to the analytical solution. Note, please read your textbook on how to find the smallest eigenvalue using power method. I believe it's also in my video lecture. Okay, so that's it using this power method, using power method. Next is, let's look at the question. What is the next question? Okay, do a maximum of 4 iterations. Okay, that's fine. Compare your result and comment your finding. Of course, numerical method will have some errors, and the error, I think, the error is small enough. In this case, is about absolute error is about 0.02. This is still good enough, lah. And after 8 iteration, this is very small. Okay, from part D, what you can conclude about amplitude A1 and A2 characteristics. So basically, A1 and A2 are in the opposite direction. Remember, there are two questions here. One is eigenvalues. So in this case, note at this problem here, after iteration 4, this is my eigenvalues, 529 from 72. The analytical is 533.33333. And this is my eigenvector corresponding to that eigenvalue. So if you do this correctly, analytical eigenvector at this eigenvalue is 1 and minus 1. And for the smallest eigenvector, okay, this is the eigenvector, and this is the eigenvalue, and this is the eigenvector. So what is a vector? Vector is telling us the direction. So in this case, if you have 0.5 and 1, so this is basically 1 and 2. 1 and 2. Basically saying that amplitude 1 and amplitude, in this case, A1 equal to 2A2. And for the largest eigenvalue, this is just 1 minus 1. So basically, this is saying that A1 is in the negative direction of A2. And this one is saying that A1 is twice the direction, twice the displacement of A2 in the same direction. So how do we interpret this graphically? Graphically, it is saying that if this is the building, before any vibration, okay, the building will experience, will shape like this when it is experiencing the largest eigenvalue. Oops, this is bad drawing. Okay, so okay, maybe I can draw it this way. So we will go this way. Okay, so this is the shape of the building because this is going to negative, this is going positive. And the other mode, okay, this is mode 1 due to the largest eigenvalue. The other mode is this way. And this is the original. So this is x1. This is 2 x2. 2x1, double of this thing. So this is the movement. So this is how you look at the vibration analysis. The vibration analysis. Okay, I think that's it for assignment number 4. So I don't know, do you want to okay, because we have not touched assignment 5 yet, I'm thinking of giving you an extension for assignment 5. How long should I give it to you? Remember, your test is on Wednesday. Anyone? How long do you want extension to be? Okay, for your information, I need to explain assignment number 5. Okay, so I was hoping that we can do it, okay, maybe on Wednesday, not Wednesday, Wednesday is a test. Tuesday, we do not have class. Okay, Tuesday, we do not have class. Okay, I need to go over your papers, because I know this week will be very busy to you. You have maybe test tonight, tomorrow night, the night after tomorrow, and so on. So please recommend me a date. Okay? If not, there's no extension, and it's due today because I need to prepare the video on the solution. Okay, I need to prepare the video solution for assignment number 5. Any suggestion? Okay, time is almost up. So it is okay. So 2 more minutes. 1 more minute.
Maybe Tuesday, Doctor.
Tuesday. Okay. So Tuesday before noon. Tuesday before noon. Okay. So Tuesday before noon. Okay. No later than that. So if you don't submit, that's it. You don't get the bonus. Tuesday, okay, before 12 noon. Tuesday before 12 noon. Okay, that's it. That's it for today's live session. So until the test, good luck, everyone. Thank you very much.
Yeah, Doctor.
Yeah, Doctor.
Excuse me, Doctor.
Yes.
Could you share the notes you just did just now in the Telegram group?
What notes? The one that I wrote?
Yeah.
I'll put on the video later.
Is it recorded?
Yeah. Okay.
Okay. All right. Thank you, Doctor.
All right. Thank you very much, everyone.
Thank you, Doctor.
Yeah, Doctor.